3.
Hi, Dr. Yang. Today we are going to give a presentation about the mechatronics project. Our products called Jerry the Mouse. Our group members has Pin-Hao Cheng, Liam Yao Tan, and Alex Wheeler. So the motivation and background for this project is the motivation that inspired us to design this project is so we watched Tom and Jerry when we was a kid. And then we think about that the Jerry is very smart, so that we want to design a product such as Jerry. Then we have enrolled in this class and we need to do the project, and we know it is the opportunity for us to design it as a Jerry. So we design it. And then if we're gonna upgrade the product, we could upgrade as a robot vacuum that can help the floor, that can help to clean the floor automatically. So in summary, for this product, we have 6 sensors on top of the PCB board so that it can detect the surrounding as 360 degrees. This product will act as a mouse, so it will move further away when it detected the object. For example, if someone tried to approach the back of the product, then the product will move forward so that it could practice a social distancing behavior.
Oh my God. Okay, hi, Dr. Yang and Grayson. So for this project, the only calculation component we have is for the distance. So as you can see in the equation below, distance is duration times the sound speed divided by 2. We divide by 2 is because the ultrasonic sensor will send out ultrasonic, and then we'll wait until it echoes back from the object. So there's a 2 times of the distance there, so we need to divide by 2. And then the sound speed we use in this condition, we assume is 340 meters per second, which is equivalent to 0.034 centimeters per microsecond. We have to change to microsecond because the duration that we got back from the ultrasonic sensor is in terms of microsecond. And next up, this is our CAD model design, mechanical components design. As you can see, we have 6 sensors, 2 on the left, 2 on the right, 1 in the front, 1 in the back. And then we use 3 Arduino boards and 1 motor control and 1 9-volt battery. I see. Okay, we have 3 Arduino boards here because each of the ultrasonic sensors required 4 legs, 4 pins, and it's not enough for us to use just 1 Arduino board. That's why we use 3. And then next up, this is the PCB designed by our own Alex.
Yeah, so as you can see, the PCB, you have the 3 Arduinos, the 13 pin rows. You can see A1, A2, A3, that's where the Arduinos go. You can see the battery closer to the left. You have the positive and negative terminal for the 9-volt. You have the switch right above that. You have the resistors 1 and 2. We were going to use a resistor circuit, voltage divider circuit. That actually, you can see in our product that didn't come into fruition. And then further left of that, you can see that's where the motor driver goes, the motor driver PCB. You can see up top and bottom on the left side, we have the motor left and motor right. That's where the terminals that connected to the motor drivers go. Back over to the right, near the middle, we have the port for the LED, and we have the port for the speaker. And then there are 6 sensors around the outside at the 4 pass-through holes that those were soldered into. Yes, and this was a double-sided PCB, so this is the top side, and then the bottom side just contained more circuitry. And you can see on the silk screen layer that there's circles around the holes for the Arduinos. Those basically showed where the Arduinos connected to each other. There were 5 connections between A1 and A2, 6 between A2 and A3, or sorry, my mistake. There were 3 between A1 and A2, 3 between A2 and A3, and then only 2 between A1 and A3. Or maybe it's, I think actually, no, it's 2 between A1 and A2, and 3 between the other 2 pairs. Anyway, it's not all equal. There's only 2 for some because we ran out of pins. So actually, we almost needed a 4th Arduino for this project, but thankfully we got away with that.
Okay, next up, I'm going to talk about the system control and programming because that's what I do. So board number 2 and board number 3, they will each detect, did I spell detect correctly? Okay, board 2 and 3 will detect 3 signals each. If I remember correctly, board 2 is the 3 in front, and the 3 that board 3 is signaling is the 3 on the back. And then 2 and 3, 2 will be controlling the LED and speaker when any of the sensors got triggered. And then 2 will send signal to 3, and then 3 will send signal to board number 1, which board 1 will ultimately decide which way does the motor turns. And then as Alex mentioned just now, there's 2 inputs between board 2 and board 3, and 2 inputs from board 3 and board 1, and there's 1 input from board 3 to board 2. The last one, the input from board 3 to board 2 is used to signal that the sensors is getting triggered so that board number 2 can control the LED and the speaker to bus. And next up, Alex will show how does our prototype works. Why is it not playing? Why is it not playing? There you go.
Hello, Dr. Yang. This is our project. This is the runaway mouse. As you can see, we use Legos for the wheels, and they don't have all the best traction. But as you can see, we have 6 ultrasonic sensors connected to our 3 Arduinos. This one here in the middle is 1, and then down is 2, and then 3. You see we have the LED right here, the red one, and then the speaker. Right now we have it so that the code has the speaker turned off because it's really annoying.
Pause for a second.
Want to deal with it.
So when I said we have the codes turned off, basically we had our code, we just used a tone function, and we had it set to middle C. We just had that commented out, but you know, that's easily fixed with just deleting the 2 slashes, and you know, there's your tone. But it really is annoying, and it drove us insane troubleshooting, and so we turned it off, and I mean, it doesn't really sound like a mouse anyway. So anyway, along with the video.
As you can see, both wheels are turning right now. And if I put my pinky over here, this ultrasonic sensor will detect my pinky, and only this motor will turn and that one will stop. Same for, let's see, this side. I'll put my finger and this one will stop and only this one will go. And then if I put my hand here behind it, it will change directions. And as you can see, every time something is activated or something, you know, scares the mouse, then the LED will pop up. And
How's it going?
let's see what else. Oh, it's right here. It's a 9.
So I don't know if you saw that battery pack underneath. Basically what happened is with our voltage divider is that we had way too much voltage drop over the resistances or the resistors that we had. So I was like, I just scrapped the old idea. And instead of having a 9 volt to 5 volt drop, we just had the 9 volt, as you can see, and then I had a 4.5 volt with 3 AA's in series, and that was used to power the system. Actually, and it was interesting because the entire system could run off the 4.5 volt, but the motors were not nearly running at full capacity. So the 9 volt it's really a parallel power system. So if one fails, then the other will help it out. So just a little bit of troubleshooting there.
9-volt battery supplies most of the power to the motor, and then under here we have 4.5 volts, which supplies power to, well, pretty much everything else. Since we use the raw input power for the Arduinos, we actually use both the 9 volt and the 4.5 volt, so if one dies, then the other will take its place and vice versa. And, oh, of course, the motor driver is here. The motor driver is connected mostly to Arduino 1 right here. Right here. And that's about it. This PCB was created using EasyEDA. And yeah, thank you for watching. Hello, Doc.
I have one last comment. The switch that you saw on the PCB and on the CAD design was not used in the final design because it was in series with the resistors, and well, we didn't need the resistors, and so the switch didn't actually come into play. But I'm sure in some further iteration we can get that to work.
Yeah, and I have another improvement can be made to our product as well. So right now there's only 2 inputs each from board 2 and 3 into board 1. If in the future, so let me rephrase it. If we have more input from board 2 and board 3 into board 1 each, then we can have the 2 boards are in parallel to board 1. Because right now, all the signals will be sent from board 2 to board 3 and then to board 1. So let's say if board 3 somehow got burned or is failed, the whole system will not work. And this is, so yeah, this could be something to be improved in the future iteration. And as you can see on this slide, this is the group member contribution. I take care of the mechanical design and the programming part. Liam take care of basically the writing part, the motivation, background, and summary. And then Alex designed the PCB and he assembled our mouse. And thank you for listening.
Thank you. Bye.
Wait, hang on, how do I stop? Oh.